Hare Krishna. Hope you're doing well. Let's get started with this question on greatest integer function and limits of sequences. It's simple. You are given two sequences and you have to talk about the convergence and divergence of both. Okay. Now, so first when you look at this one, very quickly it should strike your mind that the numerator is a higher degree polynomial than the denominator. So it should work out in a way that you will get some, this would be sort of similar to some polynomial of a degree which could be the difference when you divide these two. And honestly it doesn't matter if it was n plus 1 or n square divided by n plus 10 to the power 100 or even something like that. The beauty of limits is eventually n is going to surpass even this number, and after some time, no matter how big a finite number there is, it's always less than infinity. So this relative order of numerator and denominator in terms of polynomials, we should try to build intuition about it. Now the next thing that you can so this sequence is sorted that this is greater than equal to something that is diverging, so it is also going to diverge. Now the other one seems like it would converge, but it's slightly tricky because it's the difference of a fraction minus the greatest integer part of it, right? The pitfall that you can get into is you would obviously maybe want to simplify this thing and get something more easy to deal with, and you may start with trying to complete the whole square and then get to this part. But the point is, like you see over here, you could also take the root of just n square minus 1 plus 1, and this part you separate, this part you separate, and this simple factorization of n square minus 1 in terms of n minus 1 n plus 1, this may seem very basic that I'm calling this out, but the mindset is to avoid using, always try to avoid using complicated computations. And while practicing, even if you solve some questions, revisit them and see if there was an easier way to factorize, because then it will become, what is the term for it, some equivalent of muscle memory for gray matter. And last thing that we have to do is simply take this thing, we know that it's written as this, and the greatest integer part is this, we can take the difference and we will get this thing. Now this thing is going to 0 as n goes to infinity, and this thing is also going to 0. Because even though this is inside the greatest integer function, you can see that eventually it will go to 0. You can do a sandwich theorem and see that. And it's basic theory that we are isolating this big expression into individual parts, and the limit of this is the sum of individual limits. That's all. Quite an easy start to the question if we were to time travel back and give the exam with the same question paper. Take care. Hare Krishna.